Good morning, everyone, or afternoon. I don't know when you're watching this. Yesterday we looked at, or the last few days really, we've looked at slope-intercept form of linear equations. Today we're going to look at point-slope form of linear equations. So point-slope form really has two main pieces for it. What it looks like is it looks like y minus y sub 1 is equal to m times x minus x sub 1. Now that m is something you're familiar with, right? M is the slope of the line, which we know is the vertical change divided by the horizontal change. So that's the same as your slope-intercept form. This x sub 1 and this y sub 1 represent a coordinate point. And we use x sub 1 and y sub 1 to distinguish from the x and the y that are already in the equation and that are going to stay in the equation. So you should always have at least x and y in your equation. Everything else will be numerical value. Something else to notice is that these minus signs are built into the form of the equation. So that's going to be something to pay attention to as we look through some examples. So our first example asks us to write an equation of the line that passes through the point 3, 8 and has a slope of 4. So that bit of information right there tells us that our m is equal to 4. And then since, right, we know that points are written in x and then y, this means that x sub 1 is going to be 3 and y sub 1 is equal to 8. So those are the three values we're going to use to substitute into our form. So I'm just going to rewrite that y minus y sub 1 will go there times m times x minus whatever that value is, and I'm going to replace it. My slope is 4, and then my coordinate point, I had 3 in my x sub 1 and 8 as my y sub 1. So if I really just wanted to simplify this, I could, I'll just rewrite it here. And that's all there is to it for writing in point slope form. There's sometimes we may have to change it or clean it up, I should say, depending on those negative signs. But if we know a point and we know a slope, then we're good to go. So let's do another example. This one says we're writing an equation that passes through the point -5, 1, and has a slope of 1/3. So again, I'm going to set up my structure here, right? The skeleton of my equation. And then I'm going to fill in the essential information that I have. So my x sub 1 is equal to -5 and my y sub 1 is equal to 1. So I'm going to replace those. Just as a reminder, right? X values stay with the x values, y values stay with the y values. And then we have our slope of 1/3. So I'm just going to put that right in there. And then we do have a double negative here, right? We have minus a -5. So I am just going to rewrite that real quick. Y minus 1 is equal to 1/3 times x plus 5. So we can always clean it up just a little bit, but those parentheses around the x and the x sub 1 should stay there. We're not going to clean it up any further. We can also use this form, point slope form, to find the equation of a line that passes through 2 points, right? We're given the points -3, -1, and 1, 7, but we're not given any information about the slope. So we have to find the slope. And we're going to do that by setting up a really little table here. So I'm going to use the x and y values right from my coordinate points. So -3, -1, and 1, 7. Those are the two coordinate points I was given. And then I'm going to use that to find the slope. So my change in y, my vertical change from -1 to 7, I would be adding 8. And then from -3 to +1, my change in x, I would be adding 4. So when I write that, I'm going to write my vertical change 8 divided by my horizontal change 4, which simplifies to 2. 8 divided by 4 is 2, or 2 over 1, depending on how I want to use it. And then when it comes to writing the equation of my line, I could use either point here. So again, I'm going to write out my skeleton. That's not always necessary, but I think at this stage it's just a good habit to really see everything that we're working with. So for both of those, I'm going to put in the slope of 2, and I want to show you that even though these equations will look different, they'll represent the same exact line. Let me finish up that other skeleton here. So I could use the points, right? This is my x sub 1, my y sub 1. So x minus -3 on the right-hand side and y minus -1 on the left-hand side. And if I wanted to clean that up, then my left-hand side would look like y plus 1, and on the right-hand side times 2, or excuse me, 2 times x plus 3. And then if I wanted to use 1, 7, again, I have my x sub 1 and my y sub 1. Technically, we could call these x sub 2 and y sub 2, but we're not going to worry about it too much. I put 1 and 7. And then this doesn't really need to be cleaned up, but I'm going to rewrite it just because I can. So again, you might be looking at those and thinking, those aren't even the same equation. I don't get it. But if we think about rewriting this, we could always distribute that 2, that slope of 2. I could distribute that here, and I would get y plus 1 is equal to 2x plus 6. And then when I subtract 1 from both sides to get y all by itself, I get 2x plus 5. So this would be the slope-intercept form of the same line. And to prove that it's the same as my line using the 0.17, I'm going to do the same thing. I'm going to distribute that 2. So I get y minus 7 is equal to 2x minus 2. And then the opposite of subtracting 7 is adding 7 to both sides, and I'll get y is equal to 2x plus 5. Those are exactly the same, which means that our two equations here are also exactly the same. Either one of those would be perfect answers for this. So point slope form is super useful if we're given 2 points rather than a slope and a point or a slope and a y-intercept. Point slope form is also helpful if we're dealing with a graph where the y-intercept isn't very clear. So if I take a look at this graph right here, I see that it crosses the y-axis, right? It happens, but I don't know exactly what that value is. And even though I could estimate, we know that estimations aren't perfect. So rather than estimating, I'm going to write an equation using point slope form. Oops, not times anything yet, equals, right, we've got our x sub 1 and our slope, x minus, oops, that should have been x, y sub 1, excuse me. All right, so looking at my graph here, I need to find the slope. So I can count here, my slope, I'm going up 3 and over right 2, 4, 6 points. So that means that my slope is equal to 3 over 6, which simplifies to 1/2. And then I could use either point here. I could use either the point, what is this, -5, -4, or I could use the point 1, 1. It doesn't matter at all. I'm going to use 1, 1, just because it might be a little bit easier. So my equation would be y minus 1 equals 1/2 x minus 1. If I used the other coordinate point, it would be y minus -5 is equal to 1/2 times x minus, oh, did you see what I did there? I mixed up my x sub 1 and my y sub 1. This should be y minus -4. x minus -5. I made that mistake. It's a really easy mistake to make. We always want to use our x values first because they come first in the coordinate point. But remember, we have to deal with our y values first. So this becomes y plus 4 is equal to, oops, that 4 is a little sloppy. Plus 4 is equal to 1/2 x plus 5. Either one of these equations would be perfect. And if I was graphing from point slope form, I would use a strategy similar to the slope intercept form. If I was graphing, I would plot the given point. Oops, that says point, but I'm rushing through things today. Point, and then use the slope. So just like slope intercept form where you start with the y-intercept and then use the slope, we would plot a point here and then use the slope to finish our graph. So I'm going to leave you now to practice a little bit on your own. So you've got some equations to write, including some with slope and some without the slope given. And then you've got just a little bit of practice here, identifying those features and graphing one equation. So do your best with that. Be sure to check your answers and let me know if you have anything. Take care of yourself, be well, and I will talk to you later.